Hey, hello sir. Uh, I am Tushar Dhake. My PNR number is 23051712341002, and my project name is Raspberry Pi based concurrent object detection and live dashboard. Today what I'll do is I will give you a walkthrough of my project, how it is built, and the demo of the actual use cases being run from the project. Okay, so I'll flip the camera on the phone, okay, to showcase you the project. Yeah, so this is the project. Okay, this is the setup I have. Okay, here I have a laptop, and here on this monitor we would be running the Raspberry Pi's display. So the Raspberry Pi we've chosen is the Raspberry Pi 5 8 GB module. Okay, this is the latest one, and this red case is the custom case which comes from Raspberry Pi. uh, it has a power module. So this is the power module. Okay, which would go into the normal socket, and this is the HDMI cable, okay, which would go into the screen. Okay, so this is the HDMI. For our project we needed a camera, so this is the camera we've chosen. This is the latest V3 camera from Raspberry Pi. Okay, so I will just pause the video for a moment to connect the cables, and then we can start again. See, here it is. I've connected the cables. I'm just turning on the camera power, the Raspberry Pi power. Okay, so we already see the green light. Okay, and what I've also done is a mouse and keyboard has been connected to the Pi through the USB. So you can see this, and here is the Raspberry Pi module booting. Okay, so here is the desktop for Raspberry Pi. Okay, this is the latest version, and it's also called as Bookworm. So I will again pause the video, and then we'll take up one use case. Our use cases are actually based on the latest detections which would be required for any smart city project or a gated community or a community monitoring setup. Okay, so a few of the use cases we have is general object detection. The project actually can detect over 600 different objects in our common use. Then there is a module and code written for detection of fires. Okay, then there is a code written for weapon detection. Then there is something for accidents, and we have a dashboard integrated where all these detections can be showcased on the dashboard. So we are using computer vision with different modules for detection. The object detection runs on YOLO version 8. For fire detection we are using RoboFlow and YOLO. So as and when we come to the actual use case, I will brief you what all actual OpenCV modules we've used. So what I've done is I've sealed the Raspberry Pi into its case, and also placed the camera unit on the stand, the tripod we've taken for it. Let's go to the screen. So if you go to the GUI, let's try to focus this. We have to go to programming, and PyCharm is the Python coding platform. So PyCharm is a community based software widely used for its flexibility and structuring. Okay, hi. So this is the object detection program. I've named it as YOLO V8. Okay, and if you can see, it runs the latest YOLO You Only Look Once version 8, which has some 600 plus classes for detection. So I've trained the model on basis of this. You see when the camera module opens, the resolution would be 640 by 480. Okay, it is under the full HD for the testing purpose and also reducing the size. Okay, this is the RBG class for color videos. What we've also done is the window creation for object detection is done. Confidence level has to be high to reduce false positives, and all the detections would go to a folder called detect. So if the folder is not there, it would create a folder and all the objects will go into the detect folder. So what I've done is just opened this folder for you. For now, detection, there is nothing, it is an empty folder. As and when we start the program, objects will start getting populated here. Okay, so I'm just minimizing this thing, it is going here, and let's start the program. So the camera window has opened. Okay, so it is capturing the fan in my room. Just move the camera a bit down and see, already it has started detecting. Okay, so human face it detected. I'll just move a bit on the side. Yeah, so see this, it is also detecting my face, the glasses. Okay, what I'll do is I have a bunch of objects collected here, so I'll just show it to you and then move the camera to get the detections. Okay, so handling two cameras is a bit difficult, but I'm doing that. So there are two bags, one basketball. Okay, so I'm also trying to get that thing captured. This is how I'm holding the camera, so it would be a bit tricky. Let's come back. See this. So ball, because it's not a full ball which got captured, it is saying it is a pumpkin, but once the entire ball comes into picture, it will obviously call it as a basketball, and the entire program is running. Okay, if you see this, detections are happening and it is scrolling up. Okay, so the bags got captured. Let's see if it can capture a laptop. So this is what I'm doing. See this computer keyboard, it has already detected. Let's see if it can detect the screen. So because the entire picture was not shown, it detected it as a mobile camera, but see this, now it is correctly detecting as laptop screen. Okay, so this was the use case for object detection. So I've kept the camera down. Let's stop this. So I've stopped the program, and then we will move to the detection folder. So see this, all the objects we saw which got detected are nicely placed in the folder, detected folder. It was empty, right now it is completely filled. Okay, and if you see, even the numbering or the naming, what I have done is, see, the object was a computer, so it was correctly detected as a computer. Today's date 21st 09/06 is the file number, file name. Okay, so let's go through it once. See this, human face, glasses, man, camera, computer keyboard, mobile screen. So this is an improper detection because only a portion of the screen was shown in the camera, so obviously the program will not understand. Pens, stationaries, backpacks, books, again backpacks, again my face, computer. Okay, so this is how the detection is happening. So I'm closing this and then we'll move to the next program. So I've just populated the program for fire detection and dashboard. So see, the name is there, and this was the YOLO one which we ran before. So just run this. What I've done is I'll just show you the setup. The camera is on tripod, and because fire cannot be created, I'm using the computer screen to generate YouTube videos, and the camera will have to detect the fire in the video and give us output. So if you see, this is the terminal. Program is not running right now. Okay, I will go up and run the program for fire detection and dashboard creation. The program has started. This is the computer screen. This is the camera screen, and see this. So it is detecting the videos, the fire in the video. Okay, also giving us the confidence level. Box is drawn properly, and in case, so what we have done is we've also showing that a live dashboard can be created for the emergency response team in a smart city or a gated campus. So if the fire is detected, call ambulance, call police, call fire brigade, and what would be the geo position. So right now it is just a random geo position which is shown here. Okay, but the program can very well handle actual live locations from the camera. So the preset locations in the camera can be used. So see this, what I'll do is I'll change the video. Okay, so now I've changed the video. See this, so there is a fire in the building. Okay, this is a video from India, and see this. So even this fire, it is very well capturing with the proper box drawn. Okay, again let's see few more examples for fire. I had also used a video where my son had actually lit a matchbox, so that video detection is there in the project report. So even a matchbox light is detected in true positive manner. See this. So all the fires are getting detected. So what I'll do is I'll just stop the program, and like last time, all the evidences are collected. Okay, so the program has stopped and all the detections are in the detection folder, fire detection. So let's start. See this. So I'll just scroll through. So many places even blur images of fire are getting detected. This is the computer vision which we have designed. So it uses OpenCV's RoboFlow model, and training had to be given to the module because the fire is also a bit complicated because of the warm color scheme. And so see this, in this video you can see the fire is orange, the fire brigade is red, but only the fire is getting detected, not the fire brigade. So all these had to be put in force of the programming to get good confidence score of detections. Okay, see this is the building fire. Okay, so I'm stopping this and then we'll move to the next use case. Okay, so we are back for the use case for weapons, and what I've also done is because the objective is to have concurrent detection, the program is a mix of the fire detection from last time and the weapon detection. So both these use the RoboFlow model. I've combined the program. Okay, so let's start. So the program is not running right now, the terminal is empty. What we'll do is start it. Okay, and for detection, again we cannot have live guns, so I'm just using Google's images. One more thing to be highlighted is this is one of the most complicated program to run because the weapons detection is heavily controlled. Okay, so there are many modules on internet which have some regulations and controls as for the detection. Okay, so if try to do a good job, the detection percentage is pretty high, it detects very well. Okay, so yeah, so here is the program starting.